right, let's talk about direct substitution. If you've been doing this quite a while in algebra, if I ask you to use direct substitution and find f of 3, here's what you would do on your calculator. Probably use your calculator. You might do it in your head. 2 times, you would just plug in 3 for x. And then you would solve this out or simplify this, and you would find that f of 3 equals 98. And so what we know is if we had a graph, and we already kind of know what this graph would look like. It's a positive, so the ends are going to be up because this is even and positive, and it's going to have all kinds of stuff in here. What this tells us is if I put 3 in for x, I should get 98 for y. So I know there's a point over here at 3, way up here at 98. That point is on the graph. So you've been doing direct substitution for a long time. I'm going to teach you another method that may or may not require your calculator, and it's called synthetic substitution. So for synthetic substitution, we'll just pick another problem here. Let's do f of x equals 3x to the 5th minus x to the 4th minus 5x plus 10. And I want to substitute, or I want to find f of negative 2. So I'm going to use synthetic substitution. With synthetic substitution, you take the leading coefficient of all of the terms. So I have 3, negative 1. Now notice there's no x to the 3rd power, so I'm going to have to put a 0 for that. There's no x squared power, so I'm going to put a 0 for that. There's a negative 5 for x to the 1st, and a 10 for the constant term. With synthetic substitution, you're going to put the number that you're substituting on the outside of a little box like that. So again, the 3 came from the 5th, the negative 1 came from the 4th, there was nothing for the 3rd, nothing for the 2nd, negative 5 for the 1st, and 10 for the constant term. So with synthetic substitution, you start by bringing down the first number. And then you multiply these two numbers. And then you add, and then you multiply, 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 and then you add. So this number that's left over at the end is the answer to what I get if I would plug in negative 2 for each of these terms. So what this tells me on my graph, if I have negative 2 for x, I'll have negative 92 for y. That is a point that is on my graph. Now, I know you're probably thinking, hey, I don't need synthetic substitution. I'm going to just use my calculator, and that's fine. The reason we're practicing synthetic substitution is because we're going to need it when we do synthetic division, and you're going to want to do synthetic division because you're not going to want to do long division. Let's do one more synthetic substitution problem. Let's do f of x equals 5x cubed plus x squared minus 4x plus 1, and let's find f of 4. So I want to know what I get if I put 4 in for x. So I'm going to do synthetic substitution. So I'm going to have 5, 1 for x squared, negative 4 for x to the 1st power, and 1 for the constant term. And I'm going to put 4 in here. With synthetic substitution, you bring down the first number, you multiply, you add, you multiply, you add, and you multiply. So 321, the last number, is what I would get if I would put 4, 321, is what you would get if you would put 4 in for x. I'd like for you to try it on your calculator, plug that in, and see if you don't get that particular number.